Hello, everyone. My name is Nikunj Bajaj, co-founder and CEO at TrueFoundry, and I'm super excited to speak with Rahul Kulhari, who is co-founder and head of data science at Edge. Edge, as a platform, is connecting professionals to jobs and simplifying the talent decisions using their talent acquisition, talent mobility, and internal talent marketplace products. Rahul, it will be great if you can briefly introduce yourself for our audience.
Yeah, thanks, Nikos. It's good to be here. Hi, I'm Rahul Kulhari. Like Nikon said, I am a co-founder and head of data science at Edge. Mainly, I'm responsible for executing the vision for the company and the same time building the AI strategy and enabling AI through across our all the products. That's where I led the data science team and experts who build those AI state-of-the-art AI systems which are powering all the products which we have today.
Amazing. Thank you so much, Rahul, for the introduction and the sharing the background. So about this call today, Rahul, like our audience, as we hear from them, that they really care about learning from how companies are setting up their machine learning and data science pipelines, empowering their developers to build models and create impact from machine learning. And
Sure.
they love to hear the details around any technical details about how you build models, how you deploy models, how you monitor models, what type of problems you're trying to solve. So we'd love to keep this a candid conversation,
Sure.
and we can go as technical as we want because our audience loves more technical details as well. And with that, I would love to kick off the conversation today. Okay. So,
Yeah.
Rahul, it will be very helpful if you can tell us a little bit about your role, how your role has evolved at Edge, and what are the problems that you all are trying to solve today using machine learning.
Sure. So if I talk about my role and how it has evolved, I remember like going back to the early days, right? I was always fascinated about building a startup from India, right? And that's where I did my engineering from Pilani, and then I did post graduation diploma in advanced computing from CDEC Hyderabad, and then I was planning to go for masters in US. But in the college time, like some friends started a company which didn't work out, right? But I was always fascinated about building the startup. So then accidentally I met Arjun, who is co-founder with me at Edge, and I s- I was interested into solving that problem through the AI because that time nobody was solving talent acquisition, talent mobility, and marketplace through AI because it was very new area to work upon. And Arjun has a right ideology and thought process. Okay, these are the problems which can be better solved through the AI, and we can enable the users through the better path on that journey actually, right? And connecting the people to the right jobs at the right time actually that time. So I got stuck with that problems and I canceled my idea of going for masters in the US, and then I said, okay, let's work on this startup. And that's where I joined them as a, you can say, kind of an intern or the like junior data scientist or data scientist actually, right? That time this term was very new term actually, right? Most of the industries were using either normal roles actually. And I was always fascinated about mathematics during my entire like learning, right? And I can say I was good in the mathematics, not in any other subjects. And that's where when I got into the edge and when I started exploring these like machine learning, at that time these machine learning was not advanced the way it is today, and we were talking about so building the small and solving the small problems actually, right? And natural language processing, everything was new to me, but mathematics was not the new to me. For example, Bayes theorem and all these simple mathematics which was not new to me. And that's where I started getting my hands early on that, and by participating into the Kaggle competitions in a very private and spending more time upskilling and reskilling into those areas because I found them fascinated when I was going through the mathematics in the detailed and the same time solving the problems and understood the meaning of, okay, that's how mathematics can be applied to solve these problems. And the same time obviously computer science the processes or methodologies as well. That's how my journey started. And the time journey started since we were the new and early adopters of the AI in this space, and across many other domains and the verticals also AI was getting adopted. Actually, we didn't see the huge amount of use cases happening through the AI that time. Everybody was trying something and see if that is working or not actually. And that time I would say that few companies like Flipkart was doing good in those eras, to start early adopting the machine learning to solve the problems in very like to solve the real problems actually. And luckily with the right use cases and the right problems and the right solutions, we kept inventing and we keep building the and start like keep applying the advanced machine learnings, and which we were always focused on. We are going to build everything from scratch because nothing was available in the market actually, and whatever was available in the market was not solving our problems, right? And we thought, okay, we only have to solve everything from scratch. And like typical AI company, you always have a dependency on the data. So that's where we started innovating from the data perspective. We started adopting from innovating from the AI perspective or machine learning perspective. And that's how like the journey started, being from data scientist to the senior data scientist to the leading the team, and then started heading the AI team, and then becoming, since I have spent approximately 10 years in this company, I understand. And I was part of the early founding team actually, right? So I understood the domain, I understood the problem statements, I understood the company, I understand the competitions, and I understand that this HRTech landscape, and as well the ML landscape, because I've seen it growing from scratch to nothing actually, right? Nothing to like completely the level which is today. That's where like this journey helped me to bring that expertise on the table, so I can contribute more from that those technology perspective and AI perspective, and help aids to build the solid products and the platform, and the contribution coming from the AI space. but
It's
but but yeah, but it's all came with the, I would say the learning was always the path actually. Whatever level it is, I was spending the time on learning, either participating into the competitions, and or going through the research papers and implementing by myself, and participating into the meetups actually, right? I may not be contributing on those meetups very actively, but I was listening what people are talking about, and those meetups may be about certain tools, about discussing the research papers, and becoming part of those communities helped me to grow myself and to reach this stage actually.
It is amazing, Rahul. Like this entire journey of, like, how you have shown perseverance over the last 10 years and continuing to build on this platform, on this product ground up, and how you have used data science to completely shape up your career from joining the team as an early founding data scientist to now becoming a co-founder of the company is an inspiration for a lot of the listeners here, that like they can also use data science and machine learning to shape up their career similarly. It's very inspirational. um, awesome, great, thanks, Rahul. So I think it will be great if you can also give us maybe a quick, 2-minute background on the type of machine learning problems you're trying to solve at Edge.
Sure. So as part of our edge products, like we do have three products. One product is from the talent acquisition space, and another product is talent mobility product, which right, and the another one is the internal talent marketplace, right? See the problem, what we are solving, helping companies to simplify talent decision by helping people find internally, and helping them to workforce planning better, optimizing better. And the same time we are helping them to find the candidate from the external market through our talent acquisition product, right? If I put in a very simplified way. And the same time we are also helping companies to connect with the employees better through by helping them providing the visibility of personalized job opportunities inside the company, and same time providing them the better career development opportunities, either personalized career growth as well the upskilling and the reskilling opportunities. Now which means few because we are dealing with lots of textual data, right? Because I like we have to recommend the candidates, right candidates, and the potential candidates for the jobs, right? And jobs are always captured as part of job description, which you do see on the like if I say on public domains like link or public products like LinkedIn, right, where you do see the job descriptions. Similar kind of job description and extra metadata is available, but we are mainly dealing with the lots of textual data. So the that's where we do have certain use case of um, how do we apply natural language processing to understand the jobs and the resumes better, right? That's one use case actually, right? Second use case is we you can call it as a search and recommendation system, which is giving the personalized or right candidates at the right time to the jobs, and the same time personalized job opportunities to the employees inside the company, right? That's where our search and recommendation engine comes into the pictures. There are other use cases which are enabled through our, and all these use cases are also enabled by our knowledge graph, which has acquired the expertise across 25 million jobs and 20 million resumes, because that domain understanding is very critical for us to recommend what's right and what's wrong actually, right, and what's potential, which means it opens the possibility for us to provide the better upskilling recommendation and reskilling recommendations to you, which means if you have xyz skill today, what are the next set of the skills you should be learning and how long will it take to you to learn those skills actually, which means also help them to understand what are their possible personalized job, the career development, how can they become, like people have the different goals, objectives or careers goals in life, which means, and they look the answer of questions like how can I become the technical lead, or how can I become the product manager, or how can I become the technical lead actually, or a technical architect or cloud architect or solution architect, which lots of companies are missing out those informations and the visibility, and because of that you do see attrition happening a lot. That's where we provide them the right career progressions, which is understanding their competencies, skills, the work which they are doing in the context of the company and across their work, professional work, and give them what are the possibilities in this particular company from their career growth perspective, which takes into the multiple goals into the account. Like each multiple people have the different goals. Some people wants to move to the horizontal movement, some people wants a vertical movement actually, some people wants to the move to the really growing jobs actually, some people wants to the stable jobs or stable roles actually, some people wants to go where they can contribute more to the organizations. That's what is happening with the gen z's now. That's the typical pattern. At the same time, providing the visibilities to through our engine, providing the visibilities to the companies uh, about or like landscape view about their jobs, about the people, so they we can help them to make the right kind of decisions, like how can they reduce the skill gaps which they do have, or talent gap which they do have, and how can we help companies to become skill first organization, which means in the past companies were building the decision with respect to roles actually, but through our knowledge graph we are enabling to make them and move from the role to the skill first organizations, where role does not matter, or it matters very little bit, mainly if somebody knows xyz skills, what are the possibilities and what kind of potential they do have, and that's where we unlock those potentials actually. So mainly,
Understood.
if I summarize that, knowledge graph, natural language processing, search and recommendation engines, and the upskilling recommendation engines, again, you can categorize them into the search and recommendation engine. And what we are moving towards, like some of the prototyping, which we are trying and will be trying in the upcoming months, actually, where how can we like bring the reinforcement learning. In the past we have tried actually, right, where because we really want or enable users to make decision actually. And why am I saying reinforcement learning? Because see, if we keep looking at the historical data, decisions are always going to be with respect to the past. The time has been changing actually, so you always can't keep sticking to the past, right? So that's where you need to bring the behavior of the today and the transformation which is happening and the trends which are happening across the industry, because company has to change according to that, not because of the past, right? And that's where we have seen, like, even if you specifically focus on how data science role has evolved actually, the kind of skill set we used to look into the 2013-14, like scikit-learn, right, and a random forest decision trees, versus today look at this kind of skill set which we are looking for. We are talking about TensorFlow, PyTorch, we are talking about reinforcement learning, we're talking about the large language models actually, right? Those are becoming the basic. Okay, people should have knowledge of that. Now if I keep learning, I will be keep recommending of those kind of peoples to the jobs actually. But that's where we are evolving in that direction.
Understood. Awesome. Thank you so much for giving that background, Rahul, and describing in detail about what are the problems that your team is trying to solve. Um, in this context, like, you're solving like very complicated NLP problems, knowledge graph problems, right? One of the things that a lot of our data science and machine learning leaders ask us is, how do we structure our team? Who builds the models? Who deploys the models? How do we maintain the infrastructure, right? If you can tell us a little bit about how have you structured your team, and how many people are there, like, who are solving different parts of the puzzle, would be very helpful to our leaders.
Yes, building a team is a huge struggle actually. Still, it's still a struggle for the companies. And I've gone through that struggle actually from early days, right? And when I was working with other people to build the team, I- if you currently look at my team, I do split the team into the five subcategories actually, right? Where I do have applied scientists slash research scientists slash data scientists. That is one category, subcategory which I do have, where their job is understanding the problem statement and then building complete end to end, which include experimentation, data cleaning, data processing, and all those processes actually, until the build to the providing the handovering the deployment piece actually. The second critical component we do have as part of the team is data analyst, right? Third we do have is machine learning engineers actually, right?
Okay.
Where they enable data scientists as part of the machine learning pipelines during the by introducing the tools as part of the trainings and experimentation and deployment and the monitoring. The same time, but the time that thing is done about with respect to the deployment and the model building is done and the model is finalized, they hand over that work to the machine learning engineers who just take that model and ship it and productionize that model actually and enable the products through those capabilities actually. Then I do have AI product manager, right, whose responsibility is how to enhance and build that AI product actually, which means how we will be building and enhancing our AI engine actually, right? And that's where the problem statement gets translated from them AI product managers to the data scientist actually and the other stakeholders in the team. The last I do have a certain domain expert sitting actually, right? um, and that's where we do have few people in that, and that is very small team. Based on the do need, we keep increasing the people based on the contract need actually. But there are a few people. But if I talk about the numbers, we do have approximately 17 people in the team today.
Across these five different verticals that you
Yes,
described,
yes.
basically.
So I do have like, if I to be become if I to be very specific, then I do have one product AI product guy, right? Then I have one AI data analyst. Then I do have the four-member team into the machine learning engineers actually right now, MLE team, right? Which include one director of machine learning engineering and ML architect, and then I do have six people into the data science team actually, right? And then I do have I think five or six people into the domain data labeling team and domain experts actually.
Understood. Awesome. This breakdown is very helpful. I have one follow-up question, because you brought up
Right.
about this the fact about the AI product manager, right? So how, like, typically, like, would this AI product manager interact more with the data science team who are building out the models, or more with the ML engineering team who's helping you deploy them, maintain the models? Basically, how do you close the business gap that hopefully this domain experts or the product managers are seeing with your machine learning models, essentially?
So AI product, like, first what happens is AI product is connecting with the application product team as well, and our customer success team actually,
Yeah,
right? And keep looking at the data based on the dashboard which we have built, right? Which is helping him understand what are the problems, are we solving, are we moving in the right direction or not actually, right? And how do we make those capabilities better based on the observation of the data.
sure.
Based on that, what happens, we have internally built the kind of a, you can say, pod structure where for each capability, one large, if you are building something new as part of the quarter, larger discussion has to be put by by organizing by the AI product person. But the machine learning guys are also part of that, and data scientists are also part of that actually, right?
Hmm.
And certain discussion happens actually, right, as part of that. Now, once that discussion has happened, then small pod structure has been built, but where more mainly discussion happens between the AI product and the research scientist or data scientist actually.
Understood.
Okay,
Okay.
but as part of that, you will have the certain need where you require certain contribution coming from the data team actually, data labeling team, where you need certain contribution coming from the data analyst, sometime contribution coming from your machine learning engineering team. That's where those people are brought based on the need, and information has been translated to them actually, right? Sometime whenever like we find we don't have any need of all the people to be get involved, AI product manager does connect to those people. Okay, this is the requirement, this is the need, and these are the outcome we are going to achieve actually, and that's how your work will impact that outcome. That's where like AI product manager create that request to the data labeling team. These are the guidelines, and this is the kind of data we are looking for. This is the basic data on which you have to work upon and require provide this kind of informations to us, right? And these are the guidelines to be followed, which are defined by both AI product manager based on the problem statement, use cases, and data scientist and research scientist expertise actually, right? That's
Lovely.
how information get translated. And once all that is done, then see, every time, even if you're following a pod structure, AI product manager may be organizing and governing that, but uh, primary responsible person will keep changing actually. For example, during the build it will be the data scientist and research scientist, but during the deployment it will be machine learning engineers actually, so they will have to start
I
contributing
will
more
finish this.
in that direction.
Awesome. So this is very helpful, Rahul. Thank you so much for breaking down about how you have organized the communication within these like across these verticals, and still like continue to deliver business impact with this. One of the things that we would love to know is in this entire ML workflow of data to feature engineering to model training to deployment to monitoring. Like, give us a couple of examples where you think you and your team have come up with some innovations in the ML stack, basically. Would love to hear and learn from your experience.
Yeah. So I would say, innovation, we have done something from the data perspective, right? Uh, See, the domain in which, or the industry in which we work, machine learning and deep learning is the need, but data is always problem. We are not getting the data we web search and the product search companies will be getting, or the self-driving companies will be getting, right? So that is a challenge, because in any company people will be always hiding in a limited quantity actually, right?
Hmm.
And that's what we are trying to optimize for them actually, right?
Yes.
So that's where few innovation has to happen, where we have introduced certain tools, processes and algorithms for the data augmentation, right?
Hmm.
Which is helping us to create certain noisy data and help us to build the kind of student teacher algorithm or capabilities on as part of that, where student is trained on noisy data which has been created using those tools and algorithms, and then like largely fine tuned on the large good amount of label data which is available with us actually, right? So that's one. That's where, like, if I speak about tools which is very much critical for us to really create that data augmentation, is like evidently AI, right? Which help us to look at the data drift, right? Target drift, because in the end you have to look at those categorical features and the continuous features to make sure even you are creating the noisy data, they are in line of the labeled or the gold data actually. Otherwise they will not be helping us actually, right? So that's where we utilize these tools, but sometimes these tools does not give the answer, so we keep applying our in-house. We keep building small capabilities or algorithms, or applying certain mathematics formulas which keep helping us based on our need actually, right? That is one, I would say. Second is, I would say, like, now the machine learning pipeline has become mature, so it may be look like, okay, there is not a huge innovation in that space. But when we were building that time, we found out, okay, there is a need of the innovation actually, because no one product was solving that, no one tool was solving all the end-to-end thing. But that time, and bringing the different tools was a challenge actually, being, because integrating them with each other, right, it was a big problem. There were nothing to maintain on the data perspective. The model registries, model management was not mature actually. Now it is becoming mature actually, where we have seen coming like Neptune, Comet, right? MLflow being growing actually with that space, right? And from the deployment perspective actually, so it was always a challenge. But today I would say, from the deployment perspective, I would say we are, I would not say it's an innovation, but we look at what's the problem which we are solving, and the problem comes with what kind of scalability, latency, and the cost actually. Because startup, it's always they have to manage with the cost, right? And at the same time, you have to provide the best developer experience and the best experience to the users actually, because you
Hmm.
don't want to take certain few seconds to process and recommending the jobs, candidates to the jobs, or jobs to the people. That's where, like, based on the need, what we have done is we have utilized the tools. Sometime we have used the TF serving, sometime we have done the quantization, and for the quantization we have used the Onyx for the deployment perspective on our Kubernetes deployment actually ports, right? And then I would think the way we have these multiple tools throughout as part of our machine learning pipeline, I think that's what I would call it as an innovation. Because we have stitched the multiple tools today as part of that, because none of the one tool was solving that, and latest certain tools started problem solving problems end to end. But still, like for startup, it's always about affordability actually, return on investment, right? And um, and, and with that, like if my team would have been growing, then I would have been taken that step. But we are able to manage enhancing and keep building the state of the art work with the current team. So we didn't find any need of to moving to those. But in the future, we don't know, like let's say this, I'm really interested in this space, and I keep telling my machine learning engineering team and data scientists, okay, these are the new thought process, new technologies, new tools has come into the space, and they should be going through that understanding, learning of those tools actually. uh, it doesn't mean we are using this so we can't move to those one. So my team keep looking and these tools and the libraries actually based on their time.
Understood. These are very exciting parts that you mentioned about the data pipelines and the optimization of model for latency through quantizations, right? Techniques like quantization. Actually, this one I would love to dive a little bit deeper into. So you mentioned you have used quantization to speed up the model latency, right? Have you also tried some other techniques like model pruning or model distillation here? Like have if you compared like which one worked out better? We would love to understand that.
So for us, I would say quantization worked better actually, right?
Hmm.
See, distillation is always part of the picture actually. Whenever you are working with, let's say, large language models, actually, obviously you
Yeah.
can't deploy. And till now, all the infrastructure runs on the CPUs actually, right? Only
On CPUs.
in the production actually,
Oh,
right?
wow.
The training only happens on the GPUs actually, but all the production deployment happens only on the CPUs. Now, what we see, and we, it's not because the distillation wasn't a need actually, right? It also comes with the what are the basic, like for example, if I give the example of BERT, right? BERT was not solving the problem which we were looking for. Whatever much data do you feed, I don't think the 25 million jobs and the 20 million resumes are the less data. It's a good amount of data, right? And we find out, okay, we have to, it's not solving the problem which we do need actually. It was not able to get the right interpretation of the jobs, and it was not able to get the interpretation of the resume. I would say they were getting it, it was okay maybe, but not for good for us actually, right? So
Okay.
obviously going and then looking at the complexity of the BERT and GPT, we thought, okay, we have to find the better, cheaper alternatives actually, right? So we looked at the Distilbert, we looked at the Roberta, we looked at the Albert, and then we finalized to the Albert actually. And we also tried to do our distillation on the Alberta as well and the Roberta as well actually. Then on top of that, we have trained the different transformers based on the need or objective of that actually, right? Which is based on our data. And as part of that, what I found, based on whether the experimentation has been done from the pruning perspective and quantization perspective, we thought quantization worked better. And to give the data, right, the model before quantization was taking approximately 1200 1200 millisecond actually, which is approximately 1.2. But when you did that quantization, it reduced to approximately 200 millisecond actually
Wow.
on the CPU, right? and that's where Onyx came very handy actually, right? And Hugging Face quantization came very handy for us, right? Because it was our models, right? And we couldn't have taken the model out from their Hugging Face because everything has been built out completely from scratch actually. Because we have tried in the past what those distillation or the quantization model which are available as part of the Hugging Face space and other spaces out were not working out for us actually from the accuracy, quality, and the perspective. So we said, okay, this is what we're gonna take, and that 1200 that could have gone much less if you would have used GPU, but since based on the situation, we thought we can afford that 200 millisecond with that model right now. So we have gone ahead with that actually. So we look at latency, we look at the model size, and how much concurrency and all that will be taking up, and what will be the CPU utilization and the memory utilization. Based on that, we take into the account which one is the right model to go for, and that's where machine learning engineering team keep doing those experimentation. So data scientist guys keep providing the framework for them to do the quantization, and machine ML team execute those directions, and they keep providing us the stats about, okay, this much time has been reduced, and this is the CPU utilization, this is memory utilization, this is the concurrency, this is the latency, and if that's under the certain boundaries which we have, then we go with that actually, the best possible option. But I think
Understood.
everybody should be taking that quantization, because when we did the quantization, we also find out impact was 1% in the precision actually. Recall there was no impact actually from those capabilities perspective. It was a kind of classification system, right? And and that, I think we were okay with the 1% actually, because
Wow.
based on the
So
use
that was going to be my next question, that you basically had 85% savings in your latency at a 1% cost to your precision and 0% cost to your recall. Basically, that's a remarkable
yes.
result by using, like, simple techniques like quantization. And good shout
Yeah,
out to Hugging Face quantizations and Onyx in this regard. So
yeah,
again,
yeah, right.
very good learning for the listeners of the for the listeners basically. Yeah, for them to try it out as well. Great. Rahul, one other thing in this context, and, like, you talked about innovations, you talked about a lot of different types of models that you have built out, right? By any chance, have you all spent some time trying to quantify the end business impact of any one model, in terms of like anything related to user experience, or actually like any dollar value impact that you all might have calculated? That usually is very motivating for our listeners to understand.
Sure. So Nikon's Edge is a AI first company. If AI would
Yeah,
have not been there, then company would have not been able to create the value, right?
yeah.
By going with that language, I would say, see, AI capabilities across the products which we do have, have created the hundreds of millions of dollars of impact actually, to be right. Because I'll tell you,
Wow.
like if we look at the problem of finding out the right candidate, people think it's a same problem like web search or the product search, right? And I would say it's much more complicated than that, because that making the decision with respect to company and for candidate is always critical with respect to the company's context, the growth company is talking about that, and talking about individuals future professional future as well. We don't want to place the wrong guy to the different jobs, which can create the mess, project getting delayed, and work is not happening actually. Everybody gets impacted, and which can cost in the millions of dollars actually, right? Since people are
Right.
the core part of the any business actually. So that's where we look at all these pieces. And I would say, like, at one of the use cases, we were like helping people to get candidates from the external market, and we told them, okay, these are the job description, and why don't you get candidates, find out top 10 candidate relevant candidates actually. They took
Yeah.
approximately, let's say, they did source the candidates 3 times, which means they sourced the 30 candidates. Out of the 30 candidates, they found 7 out of 30 candidates relevant actually. And these are the candidate recruiters who were expert across the time, and they have spent in industry approximately 12 years actually, 12 to 15 years, right? Now we put our AI into the pictures. AI, so recruiter was 7 out of 30. Now let's say 30 resume, going through the 30 resume, let's assume you would have gone taken 3 seconds, 90 seconds they have spent actually, right? And out of the, after going 90 seconds, they found the 7 relevant candidates actually. When they went
Right.
through our AI, they found 10, 7 out of 10 actually, right? So faster conversion, right? Right, that's one. Right, second is what we have seen, like recommending the candidates to the job, right? Will fast time to fill has been reduced drastically actually, right?
Hmm.
And it depends for each companies because other processes are also get involved, but the conversion during shortlisting and screening has reduced drastically. Some people trust our AI system because we also have built the fair, transparent, fair AI. So they trust our AI and make the decision on that actually. So it has reduced those kind of impact actually. So the candidate discovery and matching has been more smoother actually. That's the impact, right? Second, one another use case which I will tell you. Uh, See, going back to the previous point is again, if you are able to find candidate from the internal market, internal people, that's better because you don't have to spend from the external market. External market cost impact companies hundreds millions of dollars actually, right? But think
Hmm.
about for the large IT services, if 1% requisition goes out, they have to pay to the vendors, they have to put extra cost for the job positioning, job advertisement, and engaging with the candidate. It's a too much process involved, too much time
Right.
involved, too much cost involved, which we are enabling them to hire people and finding out the potential people internally as well actually. So why to go for external? Second, from the let's look at the internal talent marketplace. 31% people leave the organization because they are not getting the right upskilling and the reskilling opportunities,
Hmm.
right? And look at situation, COVID situation came actually, right? And this that currently in the few months back, we do have a situation of the potential recession actually, right? And that's where the problems are happening. Now think about if some companies which are not digital transformation ready, which means they have the lots of specialized actually people, and specialized people can't contribute all the time actually, because they can only
Right.
contribute when there is work for the specialization actually.
Correct.
And all other time they will be sitting idle. But one of the another innovation we have done is we have the kind of upskilling or reskilling opportunities we create for the individuals, so that help them to become generalized specialized actually, right?
Interesting.
And which means the person who was only doing the Python now has the possibility and potential to do, let's say, data analyst. The person who was only doing the Java development work has the possibility to do the big data and the Android development actually,
Right.
right? And the person who was doing only the front end work now has the possibility to do the back end work actually. I'm being very specific from the technical jobs perspective.
No, that makes a ton of sense. So Rahul, sorry to
Yeah,
interrupt. Like, does the platform also offer upskilling modules as well for the candidates?
yes, our internal talent marketplace provide that actually module where we are recommending if you know Java, and then you should be learning Java and Spark and other this Spring Boot as a skill actually, right?
Oh
So
wow.
which are all the skills are complementary to each other. If they want to go through the individual skill, we also recommend that as well. But if you want us to recommend the box of the skills, then we are going to recommend, because see, people are mostly categorized into the four groups actually across the world, right? They call it as the I competency, T competency, Pi competency, and the Com competency. Now if you look at the I means people are specialized into the one area actually. T means people are specialized in one area but they have the breadth across other skill areas as well, or
Hmm.
competencies, right? And then Pi, which means specialized in the multiple areas, have the depth across multiple two areas, but have this like breadth also. Com across. If you look at the people into the really who are really innovating, inventing actually, and the startups which are really moving actually exponentially, and I'm talking about people working across SpaceX, Tesla's, Netflix, Spotify's, Apple, Amazon, Google, those people fit into the com category actually,
Makes sense.
right?
Yeah.
And people who are really growing startups actually, right? The people belong to that Pi category. Now typically companies has been into the I space actually, right?
Okay.
And that's where you have to move from I to T or Pi actually to create more value. See, if you do that, then what happens? You create more better margin.
So Rahul, so far we have talked a lot about like the overall effect of machine learning within Edge, how it has created business impact, and also how, what are some of the innovations that you have done in this operationalization of machine learning journey, right? But I'm sure a problem as complicated as this also has a challenge, also has challenges of its own, right? So would love to hear some of the challenges or pain points that you are currently trying to solve, Rahul.
Sure. So talking about the challenges as part of the machine learning pipeline or complete work with respect to training, deployment, and monitoring, I would say the first challenge is faced with respect to the training always, because when you're dealing with the data, right, and you always face with respect to the having the less availability of the data. And I'm talking with respect to the use cases which we do work upon, which is search, recommendation engines, classifications problems, and objective or goal oriented machine learning actually, where you are dealing with a certain kind of information and trying to utilize the part of the reinforcement learning actually, right?
Hmm.
Now, since we are working in a domain where you don't see the huge transactions happening like web search or the product search, so managing with the less data is always a challenge actually. And how do you solve those problems? That is a one challenge actually which you do have, and very little tools are available and very little papers are out there which talks about how to go about it actually. I think some, that's where like we keep trying and start keep using the different tools, right, to solve. And I'm not saying we have solved this 100%. It's always a iterative process to reach to that goal and to come out of those problems actually, right? And so that's where is the one tool where I would say one challenge, data augmentation and bringing the data actually always, right? The second was, see, there are lots of tools which are available with respect to your experimentation, tracking, all those perspective actually as part of the pipeline, right? But I would say adoption across research scientist and data scientists is always a challenge unless you push them and you help them to understand why that is important actually, right? Like when I'm talking about my experience with the team actually when I started adopting MLflow early, because we always wanted to take the open source path actually, right, and the community driven path, and that's where we found MLflow. So adoption was a challenge because data scientists always find, okay, why this tool is coming into my this process actually, and how will it help me. And sometime when I'm like getting the new people in, or some interns as well, right, that's always a challenge actually, right? They it's very difficult to help them understand, and they don't realize that. And I think that is changing now, but it's always going to be a challenge because you are introducing new step as part of the process actually, right? And then I think you do have the different tools actually. Some tools are focusing on different problems actually, some tools are focusing on the different set of the problems, right? For example, you can track lots of informations actually, but how to utilize that information to make the next decision, I think that's what is missing in across all the tools. For example, you did the 10 experiments, right? But why did you move from the one experiment to the second experiment, and what was your goal? You are utilizing certain insights based on your understanding of the data actually, right? But let's say some kind of a prescriptive or descriptive insights are available which may be driven by the machine learnings, like, okay, we do think if you try to optimize xyz information, then that can potentially go better actually. Some tools are providing in one way or another way, right? Some tools are doing that, but I think that's what is missing, because in that case you are totally depending on the expertise of the research scientist. But and see, it's always you're running against the time and against the cost as well with respect to the running the experiments. You always want to run the infinite
Right.
experiments, but you don't have the time for that. So how, what will be the best experiments to run? And you can't be only dependent on the human expertise. Let's say if the data and algorithm and human expertise all three can contribute, then you get the best out of it actually, right? Which leads to the right strategy. Because I was thinking about and I'm talking about one problem statement actually. We do have lots of hyperparameters actually, right? Now if we start focusing on with respect to the limited infrastructure which we did have that point of time, now what are the best experiments which we can get out actually, right? And we did run different steps to come out to the ideal optimization of those hyperparameters, and there are lots of tools for that available today. But coming to that ideal was, because I could have run the 100 experiments for the 10 features and some hyperparameter tunings around it and move to that path actually. But I don't want to go that path and see what are the basic insights which we can get, which can give us the insight. So we build additional analysis on top of that to come to the best actually, without running the 10 experiment, and get the objective in the 5 experiments as part of those tools actually, right?
Interesting.
Third one is, I would say, deployment is always a challenge actually, right? And when I say that deployment is always a challenge, because it's all about deploying the models on the CPU versus GPU. That is one.
Hmm.
Then scaling, then the latency, and then the profiling actually, right?
Hmm.
And which tool to use. And I'm talking about, we used to use one tool called Seldon actually at one point of time, right? Now, certain capability, and the point which I'm talking about is which was faced with respect to the certain capabilities, it was taking lots of time. Latency was huge actually. But when we took the same model out on the TF serving, the latency went down actually,
Oh,
right? Right, it happened. And like that was one observation maybe, right? So we faced with one of the capabilities or one of the model actually. Now the piece is, tools has to start supporting the load testing, profile testing, and all these goals as part of the deployment, right? Which gives us the idea about how best you can deploy those capabilities into the offline versus online mode actually.
hmm.
Today you're utilizing some. So what happens, these tools are ML, let's say you are using the ML flow for the deployment actually, or you are using the Onyx for the deployment, or you are using TF serving or Sheldon actually. You always, once you do, you need to do the load testing separately and get the stuff done actually, right?
Right.
But the time, I think that process can be solved, so which help people to do that better actually. See, today people don't have the right information. And I'm not talking about the mature organizations actually. I'm talking about the people who
Hmm.
are into the beginner or really going towards the mature side actually. They are facing the issue of how do I best scale these capabilities actually, right? And that's where, like, at one point of time we were also looking at the certain tools, um, which provide model, like you do have the serverless actually, right?
Hmm.
Like that, we were looking at those capabilities. Okay, are there tools which can help us to deploy the models and not consume the infrastructure all the time, and we pay only for the use actually, right? Those were
Right.
very very, and see, because if you, let's say, I do have a CPU today, but if I want to go to the GPU route, and if I use the GPU 24/7, even my service or APIs are not consuming that, still I will be paying that actually,
Right. Right.
right? So how do I get the best out of the GPUs? Because you want to have the private infrastructure which can serve the need of yours, and looking at those tools is very very necessary. And some tools are available today in the market, right? If I put a name of those tools, for example, max.io, inferred, banana.dev, which provide a serverless GPU inferences actually.
Right.
But some tools are very basic, they only works for the language models actually. And and some of the like basic classification problems actually. But think about the different use cases companies are solving, and I'm talking very heavily from the search and recommendation space, because you will be seeing lots of uh, products coming into the search and recommendation space, not from the B2B perspectives, but like we look at the Google's competition today. Niva has come, which is providing the private browsing, actually private search engine actually. Like that, multiple companies are focusing on building their search engines and getting them out, and adoption is happening actually because they are providing that value to them actually, like
Makes
u.com,
sense.
niva.com, and all that. So I think that is very critical. I would say that's a challenge again, because um, uh, for the search we do get what we are looking for, then it add value and we are able to reduce the latency, and we are better upscale and rescale our infrastructure actually. And scale, it brings the scalability automatically on the piece. And that's where we're looking at these options. But that's a challenge always, unless you don't put
That
the
makes sense.
MLEs to do those experiments, you are not gonna get out of those problems actually,
No,
right?
that
So
makes a ton of sense, Rahul. And I think you have brought up some really interesting points, starting from like working with low volume data, given the nature of your business. And here I assume, like there's been a recent trend that Andrew Wang talks about, that instead of model driven development, now you do data driven development,
data driven, yes.
right? So I'm
That's
assuming
where we
that,
are. That's where we are spending the time actually. Like last quarter, see, algorithm is, what best you can get out of the algorithms actually, or the
yeah,
models actually, right? But maximum value will be driven out by the data actually,
data,
right?
yeah,
So our team was focusing on how we can enable or more better value through data augmentation, getting the more better possible data actually. So we were
right,
running the lots of heuristics, lots of analysis on the data, and utilizing the existing previous, and then using the domain expertise to bring the better data without completely data being labeled actually, right? And then utilizing and then see what does that mean. That point is
right.
very very much valid, and it's relevant in the today's time, from the healthcare domain and from the domain of like wherever the less data is available, right? Always.
That makes a ton of sense. Yeah. And then you also talked about like some of the important, tool adoption challenge, which is something that we hear like practically everywhere. Hyperparameter search, like of how to optimize that, how to go about like this entire space that you want to go through. And then one of the things that you mentioned is you were using Seldon for your deployments, and decided to move away from it because of like one was the latency issue that you talked about. That TFServe actually had a bit better latency than Seldon. Was there anything else that you observed in this aspect that you thought was meaningful to drive this decision?
So the another thing which was another observation was, and again, like I'm don't remember 100%, but if I recall correctly, it was the memory uses as well, memory footprint, which is
Hmm.
RAM actually, which was also high actually, right?
Okay.
And so which means you require better infrastructures to more infrastructure, but let's say you could have managed in the less one actually, right? Or you go serverless completely actually, so that's always better, right?
Understood.
So my recommendation is like, if somebody is dealing with the language models actually, right? And and so language models are good to run on the GPUs always actually, right? Because you have to support the minimum latency actually. In that case, I would say go with the serverless GPU inferences always. And my like take was either use the max.io, where you do have the open source and premium stuff actually, license driven, and
Yeah.
help you. It can help anybody out actually.
Got it. Okay, this is very helpful. Thanks a lot, Rahul. And by the way, I think this talking about all these tools brings us to the last question of this session today, which is I think about the tooling in the MLOps space a lot, right?
Yeah,
And as we know that there's like hundreds of different tools available for every stage of the pipeline,
sure.
like thinking about data processing, feature engineering, model training, model deployment, model monitoring, etc., right? And I've also heard from a lot of data leaders that working with all of these tools, it seems like a lot of pain, like how to integrate all of these tools together. So, like I have been thinking about this question where what is this LAMP stack or a MERN stack equivalent of the MLOps world? What are like the few tools, could be one, two, three, 10, whatever, that you think a combination of those tools practically complete the entire MLOps journey for the user? Like what are some of those that combination of tools that according to you?
Yeah, I think there are lots of tools available nowadays, right?
Yeah.
And there are lots of permutations and the combination which you can apply
Yes.
to get the best out of it based on your organization's need. I would say what works best for us actually, and what I do say as best. See, if one tool solves all the problem, that's always good actually,
Right.
right? But there is no one tool. See, every tool has their wants to become that one tool, and they are enabling those integrations or those specific components as part of their roadmap if they don't have it today actually, right?
Right.
But I would say from my perspective, like I'll be starting from the infrastructures to then go towards the deployment actually, right? And see, from the infrastructure perspective, you always need the GPUs to be available, right? What we do use, and there are multiple companies out there, we don't use Amazon or Google or Azure for the training. We use one Indian company called E2E Networks for the training purpose actually, which provides the affordable GPUs A100, V100 actually, and which serve the need. And it's cheaper as well, and it also provides you the credit actually. So if you are a Indian company, I would say go for it actually. Multiple companies use it. In US, you do have the different alternatives like E2E available in India, like that multiple companies out there in the US actually. Now, talking from the data perspective, right? I would say data perspective always, I would recommend DVC always supposed to be used actually. It will help you even because you will be doing multiple data cleaning, data transformations, all that will be happening because you are going to spend good amount of times. If you use DVC, it provide versioning, it help you with respect to the regulations as well actually, right? If any AI regulations come into the pictures and to become the provide the better insights about it, then you need to use the DVC. That's what is my 2 cents on that. From model deployment and model training perspective actually, right? I would say as part of that, there are multiple ideal tools actually, right? And I would say ideal tool can be maybe like Neptune, Comet, right? Comet.ml, or let's say what you guys are doing at TrueFoundry, right? Based on the limited exposure which I do have to your tool. And um, and then that getting integrated with your, let's say, Git, right? Because everything needs to be connected. And when I'm telling this ideal tool, I'm looking at the multiple objectives. Reproducibility is always the option, and that option should be available, and regulations as well, AI regulations actually, right? And which means it help third party to also be reproducing your capabilities or the models as it is based on the data. So then these tools integrated with your, plus then certain hyperparameter tools actually, there are lots of out available out there actually, like Ray provides something, right? And hyper opt and all that. These are the tools available. And then from the model building perspective, right, I would say that today there are, based on the problem statement available actually, right? Hugging Face, people want to take the Hugging Face as it is actually. TensorFlow is there, PyTorch is there, right? And I would still stay, we do gonna stick with all these three actually, unless we are solving the regression problems or decision trees problem. Then I would say the Cat Boost is the another tool or the libraries which can be used, right? And then on top of that, I would say for monitor the deployment perspective, I would say go with Onyx actually, because we are able to get the best out of it actually, right? That's where. Or if you want to go with the serverless, then I would say Mex.io or Banana.dev or Inferred actually. These are the three companies which I have come across. You go with them actually, right? And then obviously like one another piece, see, this is all I'm talking with respect to the during the development actually, right? But when you're going to work with the production, then you need to add multiple other tools which are compatible with all these existing pipeline, which means for the data quality, either you write by yourself or you use the great expectations, or you use some kind of data cataloging or data discovery products actually, which help you to understand complete and help you to understand about the complete data lineage as well actually, right? But and then on top of that, see, great expectation provide a dashboard by itself about the data quality, about the certain constraint which you have written down. But we have built custom dashboard in the Streamlit actually. So for visualization we use Streamlit most of the time actually, right? So that's, and for uh, and for understanding the data drift, right, or different kind of other analysis with respect to the data, then you need to use the alibi detect or evidently AI actually. That's what I would recommend. Or sometimes you have to implement because some algorithm which you want to do, don't find them available there, so you have to write it. But that's where I would say these are the two, and we have written our basic other stuff as well actually, right? And
Amazing.
I think
Sorry. Go ahead.
I can talk about other tools which like people use alternative the Jupyter Hub and all that, but I think that is given. I think that's what is the best possible infrastructure people have to get out. And monitoring perspective, I would say right now I would say no tool which I have come across serve the need for the complex problem statements like search and
Mm.
recommendations. Actually, for
Mm.
classification, you will find out. For regressions, you will find out basic, right? But even if you look at the demo of the certain products, actually, and which I've done in the past, they don't show the demo for the complex problems, and that's what organizations are solving. See, house loan prediction, any those are the college projects actually, or the competitions, basic competition for the interns actually, or just actually, right? You will not be using those tools to solve those problems actually. You'll be solving the complex problems, and that's where you require better tools from the monitoring perspectives, and we have not come across. So what we have done, we have deployed our own dashboard using Streamlit based on the information being captured, and we use the kind of ELT tool to get the data from one place to another place and transform, and then based on the need we transform and bring the dashboard in the in the Streamlit actually, from the monitoring perspective, which provide the information to different data scientists and machine learning engineers and data analysts and the AI product managers to act in certain ways, right? Which means talking about metrics like MAP, the technical metrics, MAP, NDCC, MRR, ERR, precision recalls, all these. In addition of that, business metrics, and in addition of that, latencies, availabilities, and all these actually, right? So I think that's where coming to the one tool is always going to be a challenge actually. It's going to be a journey. You're not going to get, from my perspective, is it's not going to be available in the next 1 year actually. After that, maybe, because lots of innovation is happening, crazy innovation, right, across the companies, like what you guys are doing and other companies are doing, may able to bring that on the table, right? But right now I don't see that happening actually, and so till that time companies has to integrate multiple tools.
Yeah, so like Rahul, I think we lost you for a brief moment, but really appreciate you mentioning like this entire suite of MLOps tool, which I'm sure our audience will benefit a lot from. And most importantly, I've noticed that like you have mentioned, most of the tools that you are using in your pipeline are actually open source. So I'm sure that it also gets them the finance team approval much faster.
Right.
Um, but Rahul, I really appreciate you taking this time and joining us for this session and sharing a lot of your insights, building uh, machine learning models and operationalizing machine learning for the last 10 years with Edge. Thank you so much for coming in, and we look forward to seeing you build great things at Edge.
Thank you, Nikunj. And I think it was an opportunity for me also to talk about from the ML landscape perspective to the your audience, and also to see what you guys are building at TrueFoundry, right? And hope you like find what you're looking for and you're able to solve the problems, and definitely which serves the need of the become the one tool actually in the end, right? So, like, yeah, thank you.
Thank you. Thank you for all the good wishes. Thank
Yeah,
you so
thank
much.
you.
We will keep you posted. And Rahul, if it's okay, like we will actually draft this video that we have taken into a couple of different formats, like a blog format or a podcast format, or maybe publish a few snippets of the video. We'll share it with you before sharing it otherwise. But that's the intent here. Is that okay?
Sure, sure,
Cool,
sure.
cool. Awesome.
Okay.
Thank you so much,
Okay.
Rahul.
Thank you.
Thanks, Vivek.
Thank you.
I'll disconnect now.
Bye.